Good morning, everyone. Welcome to today's section on Hack 365 Global. My name is Judith Monday. I'm a staff of Upgraded Era Solutions Limited. So, once again, welcome. Today we'll be looking at offensive web operations. That in that regards, we'll be looking at the red team's entry points. So, in this section, we will learn how to uncover how attackers breach web system. We learn how to map out vulnerabilities, and we will exploit how to execute real-world solutions. We will also learn some red team tactics and tools in action through this live guided demonstrations today. So feel free to participate, ask questions where you're a little bit confused or where you need clarity. The chat box will be open for you to put in all your questions, and we will try our possible best to profile solutions and attend to all your questions. Um, so with all that being said, please get ready, turn on your systems. If you have not joined, join. If you have somebody that will be interested in this section, kindly share our links, encourage people to join. We promise this will be a very interesting session that you wouldn't want to miss at any point in time. So our office is also available for those of you that want to come into the premises. We are all set. So Mr. David Idowu will be taking you through the session. So sit tight and let's get started. Thank you very much once again. So Mr. David, over to you.
For today, we're going to just take a little bit of introduction, which has been done already. Then we'll take a look at the theoretical approach to learning, we'll have the practical session, then we'll have the room for discussions and questions. Okay, so the objective of today's session is, first of all, to understand what offensive security testing is, understand the basic difference between penetration testing and red teaming. We also want to look at how to exploit common types of web vulnerabilities. I'll be taking a case study from the OWASP top 10 offensively, and also want to check for how to use essential tools like Web Suite and the browser development tool. Okay, so by way of introduction, what are offensive web operations? So this refers to the use of web application exploitation as the primary method for achieving initial access during red teaming or ethical hacking operations. So unlike traditional penetration testing, red teaming mimics the action of real adversaries, often beginning from web-facing assets. Now, what does it involve? Offensive web operations refer to the practice of using offensive techniques to exploit web applications during teaming engagements. So red teamers often aim to mimic real attackers and often begin their campaign by targeting internet-facing web assets. So before before the process of exploitation of an infrastructure or a system, majority of them have web assets that are public-facing or that can be accessible. Red teamers often want to start their process from there. So if they can compromise the web assets, then they can have quite a number of information that can be used to compromise the whole system. So unlike conventional penetration testing that may have limited scope and predefined targets, offensive web operations simulate realistic attack paths. The goal is to find exploitable web vulnerabilities, breach the application, gain access to internal systems, and achieve broader objectives such as data exfiltration and domain dominance. Why web applications are a common entry point? So the question is, why are web applications a common entry point for red teamers and offensive security engineers? This is because most organizations expose a wide range of web applications to the internet, including the likes of customer login portals, API endpoints, web-based admin dashboards, content management systems, legacy systems repurposed with web interfaces. These applications are frequently riddled with flaws, including outdated components, insecure authentication, misconfiguration, and poor coding practices. Because they are externally accessible, they become a natural target for attackers. So this implies basically that for every breach that a red teamer is trying to achieve, or that an offensive security engineer is trying to achieve, web applications are more or less the entry points for them. Reason being that one, they are externally accessible, and then they contain a wide range of information and data and test vectors that could be easily tested, the likes of APIs that are used in the system and dashboards, admin portals, and the likes. So this gives a room for a lot of misconfigurations and authentication flaws that attackers could use to gather information, gain dominance over the system, and then properly breach the system, depending on the case scenario. Now, we're going to be looking at a major difference between red teaming and the penetration testing mindset because they sound alike. So, for penetration testing simulates opportunistic hackers. What this means is penetration testers are employed to test a system for the sake of remediation. So it gives a penetration tester is a hacker that is aspiring to gain more knowledge, and then he uses this opportunity to leverage knowledge he finds on the system for the sake of remediation. So a pen tester is employed for a reason of testing an infrastructure, so he can find the flaws, and then those flaws are properly remediated. Now, on the other hand, red teaming simulates sophisticated adversaries. So basically, in red teaming, you don't want to think of a red teamer as a penetration tester because he is more advanced than a penetration tester. A red teamer is employed to actually breach a system. What a red team engineer does is to properly breach a system and ensure that the aim of a red teamer is to breach a system. The aim of a penetration tester is to test for vulnerabilities and fix them. Second of all, penetration testing has a short engagement window, meaning, for example, a pen testing assessment can have a duration of a month or two that could cover over a period of time. So this means the engagement is quite limited because you have a limited amount of time to test, find vulnerabilities and fix them. Red teaming involves a longer engagement. This is because most red teamers have the abilities to stay as advanced persistent threats on a system, which is a threat that persists on a system over a long period of time up until it is figured out. That's what makes it an advanced persistent threat. So engagements like that are actually longer term. Penetration testing is often noisy. This is because the aim of a penetration tester is to just find vulnerabilities and fix them. So the tools used, for example, tools like Nmap and the likes, which are often noisy in their operations, contribute to the noisiness of penetration testing. This is because it comes with a level of agreement between the tester and the organization in play. For red teaming seems to simulate real-world adversaries, so there is a large emphasis on stealth. So, for example, a red teamer might not use tools like nmap when he's trying to map or scan a particular given network. This is because he is trying to simulate an actual adversary who would do that noiselessly. So there is a large emphasis on stealth. So the goal of penetration testing is to find vulnerabilities, while the goal of red teaming is to achieve strategic objectives. Okay, so let's just take it right off the bat. So first things first, what's reconnaissance and enumeration? Reconnaissance is the process of gathering information about a target before launching an attack. Enumeration involves probing the web application for more detailed information about its structure, functionality, and potential weakness. Now, these both together form what we call the information gathering phase. So when you are performing a recon, you're trying to gather information about a target before you launch an attack. So you can gather information either actively or you gather it passively. When you gather information passively, you're trying to gather information about a target without you necessarily interacting with the target. This involves using the likes of open source materials, the likes of Google, social medias, to gather information about it, target A. So by doing such, you're not necessarily interacting with the target. So you are gathering information from the target passively. On the other hand, when you're gathering information actively, you're interacting with the target to gather information about the target. That's where the likes of tools like nmap, netcat come into play. So when you perform an nmap scan on a target, let's say 10.10.10.10, and you perform an nmap scan on such targets, what you're doing is you're interacting with the target to gather information about the target. So that's what reconnaissance covers. Enumeration, on the other hand, involves probing an application for more detailed information about its structure, its functionality, and its potential weakness. So what you're doing when you are enumerating is you are poking the application, or you are checking to understand how the application works, trying to gather enough information about the structure, the functionality, how does it operate, what is the structure like, how was it written, what is its functionality about, and then from there you're able to gather potential weaknesses for the sake of information gathering. Also, look at passive reconnaissance. So passive recon involves collecting information without interacting directly with the target, as earlier discussed. This includes Google docking, which involves using advanced search operators to find sensitive files, directories, and endpoints. So platforms like exploitDB on Google offer quite a library of sensitive directories and endpoints that can be tested for search operations and the likes. Also, Shodan and Senses. Shodan.io gives you a platform where you can scan for IoTs and servers around the world that have revealed exposed assets. So with a platform like Shodan.io gives you an environment where you scan for every app, every web app, every server, potentially actually a hardware server that is registered. You can scan the IP address and it helps you reveal assets that are exposed. And then from there, you can begin whatever it is you're looking for. Also, GitHub links. So, searching the public code repositories on GitHub web applications can accidentally expose credentials or keys that were used in the development of the web application. Yes. So, still under reconnaissance, there is something called subdomain and host discovery. Remember, our focus for today's session is web application or is a web application. Now, subdomain and a host discovery. Now, first of all, what is a subdomain? A subdomain is a domain that exists under a domain. That's why it's called a subdomain. Meaning, The parent domain can have so many subdomains as long as it bears the domain name, because the domain name is the parent. So you think of the parent as think of the domain as the parent. I think of the subdomain as the number of children it can give birth to. Now, subdomains can reveal forgotten applications, developed environments, or internal tools. So by enumerating subdomains, the same way you enumerate for directories, you can find a number of subdomains that exist on a particular domain, which can reveal forgotten applications, maybe test subjects that were used during the application, during the um, development of the environment, which can often reveal sensitive information and the likes. Now, we also have, so for some of the tools, we have Hamas and Sublister, which is used for brute forcing subdomains in order to reveal the subdomains that exist on a particular domain. We also have crt.sh, which is a certificate transparency logs to find subdomains. Then we have brute forcing techniques, which involves using checklist, word list to uncover posts on a system or even subdomains too. Yes. Now we move to web technology fingerprinting. So this involves understanding the attacker's stack in order to help tailor attacks. So one of the first things you want to do is you want to identify frameworks that are used on the system. That's where tools like Wapalizer and WhatWeb comes into play. So tools like Wapalizer and WhatWeb help you to identify the framework used in the development of the application. For example, frameworks like Laravel, Express, the server types like Apache, and Nginx, and even platforms where it runs, platforms like WordPress and Drupal. Localizer does a great deal of job in identifying these frameworks for you when testing an application. It automates the process for you. You don't have to find out these things yourself. By simply just loading the application in the browser, Localizer can help you identify the framework so you know you're working on Laravel, or the application you're testing, the application you're working with uses the Laravel framework or Angular or whatever the case is. Now, also JavaScript libraries. So it helps you to identify things like the jQuery, whether it's an Angular framework, and the React versioning can also indicate specific vulnerabilities, the same way Apache versions and Nginx versions. PHP versions also can indicate specific vulnerabilities relative to the version that is being used on the test subject. Yes. Also, now we move to directory and file enumeration. So, directory searching, tools like dir search, ffuref, and GoBuster help to discover hidden paths like the admin paths, the test paths, the conflict paths. Paths like this often exist on test subjects and test applications, which can be used, which are used for several reasons. For example, a path like the /admin path can be leading to an admin page or an admin login portal. A config path can lead into a directory that hosts config files and sensitive information. It also helps you to search for file extensions like .php, .bak, .env, .sql, .zip. Files like this can be lying somewhere on the applications. It helps you to enumerate such that you can find sensitive files like this. File enumeration also helps you find a robots.txt file, which most times hints to sensitive parts or sometimes sensitive information themselves. Now, then we move to vulnerability discovery. So, in vulnerability discovery, you're basically learning how to locate and analyze inputs. So, in red teaming, one of the first things you want to understand is query parameters. For example, ID equals to 1. Sometimes it might not be equals to 1. It could be ID /1 or something else entirely. Also, the post form data, which is used as a medium of interacting with web application, where you feed the application information. Also, HTTP headers, likes of the user agent, X forwarded for, and the PT headers, content security policies, allow origin, and headers like that also are things you want to put into consideration. Some applications cite their misconfiguration from missing headers, which foster, which helps in finding vulnerabilities and their exploitations. Also, the JSON and body fields, which help also understanding these fields help to analyze data properly and understanding how an application works. So, in liquid discovery, what is fuzzing? Fuzzing involves the process of injecting malformed data or payloads to trigger unintended behavior. So, it involves you rapidly injecting data or a payload to a target or an endpoint to understand its behavior and understand how it works. So think of forcing like brute forcing. Another word to force is to brute force. So tools like the Bob intruder, FFUF, and the W force are often used in forcing. This works differently from tools like Hydra, because Hydra is used for password brute forcing. Intruder and the intruder can also be used to brute force passwords because both gives you the flexibility of checking of brute forcing several parameters. But tools like FFUF and WForce are often used basically on web applications to either force for directories, subdomains, and whatever the case is. SQL injection. So basically what we're looking at the major vulnerabilities that you want to check for when you're performing writing or an offensive operation on a web application. So an SQL injection, you want to exploit login forms or search bars to extract credentials or bypass authentication. Also, you want to use SQL map for automation and database fingerprinting. So you also want to discover database schema, user tables, and look at the possibility of dumping hashes. So basically, with SQL injection, you want to see how you can malform or disauthenticate the web application's database to either extract credentials or to bypass authentication for automation of this process, or you want to fingerprint the whole database, which involves you scanning to be having access to the database and then scanning through to understand and extract the shitstone of data that is found there. Move to cross-site scripting. As discussed last week, cross-site scripting involves the process of injecting either HTML scripts or JavaScript code into an application that does not properly validate or sanitize this, which helps you to execute the script as part of the working process or operation of the application itself. So cross-site scripting can either be reflected or it can be stored. So if it's reflected, it means there is an immediate payload execution. It means the moment you get a response, so it reflects. If it is stored, it means it is persistent in the database and it affects every user. Cross-site scripting can be used to steal session cookies, redirect users, and also to drop malwares. Also, we want to look at file upload exploits. So this involves you exploiting a flaw in an application that does not properly validate how files are being uploaded to its system, such as the file extension, the file size, the file content, and things like that. Applications that do not properly validate such parameters are often regarded to be file exploitable because by uploading malicious files, you can bypass authentication and you can also have remote code execution. So this can also lead you to uploading web shells, bypassing filters using double extensions. For example, .php.jpg. So in an application that wants you to, that just strictly enforces the .jpg rule as a file extension, but doesn't necessarily check the content of the file itself, can still bypass this by using double extension. So now this is why red teaming has an edge over penetration testing. Because in this case, now that you're looking at it offensively, you're looking for every means possible to actually gain access. So now you now discover there is something called using double extensions. So you can use .php.jpg to save a file format, which is exploitable. Also, you can also upload web shells that will give you remote code execution in the long run. Or you can also spoof the content type. So take for instance, an application uses a content type of, let's say, application and JSON, then you're trying to do something else. You can spoof the content type to fit what you're trying to gain. Now, command and code execution. The command and code execution, when you're trying to achieve this, you're trying to leverage unsanitized inputs and system commands, for example, pinging and the likes of it. So when you find an application that does not validate or sanitize the inputs in the system commands, you want to find how you can perform command execution, which most times can be used to spawn a share via operating system commands. And then from there, you can also list contents of the web applications, even without spawning a shell, that is on the application itself, just by using code injection, you can extract information from the infrastructure itself. Now we look at request forgery. Now, request forgery is often divided into two. There are the client side request forgery and the server side request forgery. Now, client side request forgery involves you tricking a user into performing an unintended action, leveraging on his or her authentication session. For example, with client-side forgery, it is possible to change a user's password to a web application or to his own account without him knowing, but you used his authentication session. Think of it like this. You log into your bank app, and then while logging into your bank app, you also view, let's say for instance, you view a blog or another website that is actually a malicious website because a hacker has embedded malicious code into it, a piece of malicious code into it that tells your bank application that, hey, I want to change my password to, let's take for instance, 12345. Now, because you have an authenticated session on your bank app, which is still running, the bank app is going to accept such request because it is coming from your session. So basically, you are forging a request on behalf of a client. Now this occurs when applications do not use anti-KSRF tokens when sending requests. By so doing, attackers can easily forge requests on behalf of clients and users, thereby making users unable to perform, to have access to their accounts or whatever the case is. Now, that is on the client side. Now, on the server side, it involves you tricking the server into making requests to itself or to internal services. For example, you have a system or a server that uses the link http forward slash example.com forward slash profile picture, blah, 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 blah. Point is, the application uses a particular link to retrieve the profile picture of all of its users. An attacker can edit that and provide it with another link instead. Take, for instance, let's say https localhost forward slash admin, and then that way the server would make a request on behalf of itself, and it will be able to have access to internal services because the request came from the server itself. So on one extreme, you can forge requests on behalf of clients. On the other extreme, you can forge requests on behalf of the server itself. That way, you can gain access to internal resources and, and files, sensitive files, and whatever the case is, by just redirecting the server or making the server perform arbitrary requests. And this can be used to retrieve AWS metadata or even reach internal dashboards. For example, localhost on port 8080. Now, web shells and post exploitations. Now, after successfully exploiting web shells, attackers aim to maintain access, escalate privileges, and pivot internally. So, offensively, you want to maintain access upon exploitation such that you cannot just be kicked out at any time. This is where red teaming applies because you're trying to become an advanced persistent threat. So doing, you'll find a way to keep your access or keep your backdoor open, try to escalate privilege, or even pivot internally. So the first thing you want to do here is you want to understand how deploying web shells work, and then how do you deploy web shells? By uploading reverse shells. So we have the likes of PHP reverse shells with PHP. We also have MSI Venom, which helps us get reverse shells, Chopper, China, VV, and the likes of it all. Metasploit does a great deal of that by giving us metadata sessions as reverse shells on applications that have been exploited. Now, after deploying the web shell, you want to find a way of managing the shell. Now, how do you manage the shell? By interacting with browsers, netcats, or even with reverse connections. Also, you want to stabilize the shell by Python sudo terminal, which was something we executed in our last session. So you want to stabilize the shell from either a shell to a daemon terminal, or whatever the case is. Privilege escalation. You want to discover SUID binaries and misconfigured cron jobs. This helps attackers in knowing how to escalate their privileges. You want to exploit weak permissions and expose configured files. Tools like leanpeace, PSPI, and also commands like sudo-l can give you proper information about um, the permissions that are currently on a system and how to go about escalating your privileges. Also, harvesting and reusing credentials. You want to extract credentials from config files, look for files that have .env extension, config.php, settings.py. You also want to try storing credentials on other systems or other accounts. Also, finally, you want to look at how to bypass defenses and the methodology of bypassing defenses. Now, basically, web application firewall bypasses. The first thing, one of the most common ways is by encoding your payloads, either probably a base 64, a hex, or a Unicode. Also, you want to use headers like the X original, URL header, X forwarded for headers. All of these headers have different things they are used for. You have the content security policy header, they allow origin header, same site, same origin headers. These headers perform different activities and functions. Some of these headers are used to authenticate that every content from an application must come from the same site and from the same origin, such that an attacker cannot just embed content from another application into another application. So headers like this are always used when building applications. Now, I want to check for, as one of the methodologies of bypassing defenses, capture and rate limiting. So in situations where you have captures and rate limiting involved, you can decide to use proxies or use Tor for IP rotation. What IP rotation involves, what IP rotation entails, involves you bouncing your IP address at the same time from one system into in such a way that the web application thinks multiple requests are coming from several IP addresses. So it just rotates the IP addresses over time. Take for instance, you have an IP address. You have a device IP address of 192.168.0.1. With IP rotate, you can set a range of, let's say, 1 to 100. So you can perform several applications, several activities or one activity using 192.168.0.1, 192.168.0.2, 192.168.0.3. That way, you've been able to bypass capture or bypass rate limiting because the request is coming from several IP addresses at the same time. Another way of doing that is by doing it in such a way that it makes the request look as though it comes from different browsers. So it doesn't come from the same origin, it bounces off. And then situations like that also, yes. Also, you want to implement time-based attack tracking. Yes, you want to monitor the time it uses. If there's proper rate limiting, you want to see how you can do that. Then you want to break basic capture using OCR tools or by bypassing weak logic. So with this, we've been able to understand how offensive security works, and basically we've been able to see that it's more like a step further from penetration testing, which everyone is conversant with. So moving to the practical session, and we're going to be using the test application that was used last week, which is our overseas shop. And for the sake of this, we'll be using our labs. So on our labs for today, we have a lab on the advanced section and a category, lab category, offensive operations, and we'll be working with the subcategory, web application operations. So we'll just head over to our labs and begin our practical session for the day. Thank you very much. So we'll head over to the offensive operations category of our advanced labs, and we're working with our web application operations. So we see that we have a number of tasks here for us to do, which we are going to work with for today. So here we have a prerequisite task that tells us how to install the OWASP shop. So in the next few minutes, everyone can just run through this, both the physical and the online audience, on how to have this shop running on your computer. So we can see that this shop is an intentionally vulnerable application used for learning web security. So we have two easy ways to get it running in your system. And we have the instructions. So this should be the first thing everyone should run on their PC. I have this shop running on my PC, so I do not have to do this again. But for those of us that do not have this shop on their PC, please just follow the instructions. So then this shop, once, upon successful completion of this, you'll be able to have this up and running. So feel free to follow this step by step, and then you can use this shop. So we're in our juice shop, which is obviously from the name says it's a juice shop. And then we have an application that gives us variety to buy and sell juices. So we'll just explore the functionalities of the application before we begin anything. So we see we have a large catalog of things to use here. We have the customer feedback form. There is an about page here, and other things right here. We also have a section for us to log in. We have the languages page. So I think for the sake of this exercise, let's head over to our labs. And we see that we have quite a number of tasks for the day. So we still have a task that requires us to log in. It's an admin, says login admin injection. Another task says open access control by giving other baskets. Another says open access control. Another says open access control by logging in as an admin. We also have a process scripting task, an API only process scripting. We also have admin registration, and there's a task here that says payback time. So overall, we have about 7 tasks for today, and we'll see how we can finish up these tasks in the course of this session and hopefully find other vulnerabilities as we explore the application. So the first task here says we should log in. So this task covers understanding SQL and SQL injection. So websites use SQL to talk to their databases. From our lab, it says when you try to log in, the site runs something like select from users, where the username is your username and the password is your password. So this checks, is there a user with this username and password? But here's the problem. If the site doesn't check your input carefully, you can inject SQL, meaning you can actually change the query by typing in smart tricks. Now, for example, an example of an injection, when you try logging in with a simple code that says asterisk or 1 is equal to 1 dash dash, and the password will leave everything to be blank. What the server says, it says select from users where the username is this, and the password is empty. This is true, and it returns the rest into a comment. SQL ignores it. The result, database says, yeah, this is valid. And just like that, you're in. So what is the task for this lab? Is use SQL injection to bypass the login form and break into the admin account. Type complete when you're done. So first things first, as discussed last week, we always want to go with our burp suites. So let's just open our browser in burp suites and head over to this shop right here. So hold on. So as discussed earlier, you can see the load of functionalities on this application. So first things first, we want to create an account, and let's create an account called um, that's Gmail. There's password of 1, 2, 3, 4, 5, 6, 7, 8. And password 1, 2, 3, 4, 5, 6, 7. The mother's maiden name. Just register. Now we can see that we successfully completed the registration. Now the sign in is monkey. Then let's come. 1, 2, 3, 4, 5, 6, 7, 8. Sure. So as you can see, we have logged in into our application as monkey. If we go into our HTTP request history, you can see that there is a whole lot of process here. Now, if we go back to our labs, our task is for us to use SQL injection to bypass the login form and begin to get admin account. So what we want to do, first things, login this time around. Let's see, admin, invalid email or password. Let's look at the history. Let's log in here, and we'll see the response code of 401, which is unauthorized because we have an invalid email and invalid password. So, of course, we need to know the admin email. We also need to know the admin password. So, what happens when we type in a regular query just like this? The password we put in is the login tells us invalid email or password. What happens when I make the password regular number, invalid email or password, put password to the admin. Okay, we find a different type of error code. This object. Now let's take a look at what happens at the back end. Now, let's quickly send this to repeater. Now, in your repeater, to expand this, you see there's an SQLite error. It says select from users where the email is this and the password is this and deleted at is null. So this is where we are getting this error because this is not presently on the database. So what we can do is to try to see how we can provide it with queries for us to bypass this syntax that it's using. So to do that, we can try admin this, It's supposed to work. Let's leave the password as admin. It says invalid email or password. Stop the line. Now, because we are going through offensive, we have to keep trying until we get what we're looking for. Right? So what happens if I try to comment this out? It doesn't work. Let's try another one. Let's try the or equals to 1. Well, tells us objects. To analyze this again, okay, assign this to repeater. Try to okay, so we discovered that there is a difference in the error it's throwing us. This tells us that there is an unrecognized token here, which happens to be the password token which we provided. It says it is unauthorized or it is non-recognized. For the second one, it tells us there is a syntax error, meaning it accepts the email, but it's not accepting the password. What we can try is to comment the password out by doing this. What we can try is to comment the password, and now we are in. So by doing such, we've been able to log in to the admin by bypassing the login form using SQL injection. So let's just brush through what we typed in. So this we type in a syntax, or 1 is equals to 1, then there's a dash dash behind it, which is supposed to be the comment. Now, what this basically means, if we go back to our repeater, which is the request that was earlier on set. In our first request, we discovered that there was an error that emanated from an unrecognized token, which was the password, which is what happens when you try to log in to when you try to log in a long password. You have a password that is not recognized, so it goes back an error message to you. So we found that there was an unrecognized token here, and then because of that, it can't find it inside. But for the second request, we gave it an email where it said the email should be or 1 is equal to 1, and the password should be admin. This time around, it said something different. It said there's a syntax error, meaning the email went through, meaning it accepts this email. Why does it accept this email? The reason is because the way SQL works is it tries to check to see how what you're providing it with matches what is inside the database. What this basically means is when you type in the email to be column or 1 is equal to 1, meaning 1 is equal to 1. For example, for mathematically, 1 is equal to 1 is always going to be true because 1 is always going to be equal to 1. So that is true. So SQLite requires that, okay, yes, that works. That is fine. And of course, one is the first user on the database. And then, but now we provided you with a password called admin. So it threw us an error emanated from the password saying there was a syntax error. So what we did was to comment the password out, meaning just to go with the syntax being true, meaning 1 is just equal to 1. So that way, if it's valid, log in, and that was all we're able to do. So we've been able to log in to the application as the admin. And as you can see, we found the admin's email happens to be admin at juice-sh.op. So having done this, we can say we've been able to finish the first task here and just click on submit. Now, the next task here says viewing other baskets. Access control is what stops users from seeing or doing things they shouldn't. For example, viewing someone else's shopping cart. We spoke about privilege escalation last week, and we mentioned horizontal privilege escalation, which is most likely referred to as an IDOR, an insecure direct object reference. Now, in a scenario where you're trying to break access control, there is a scenario you're logged in and you're visiting your own basket. In a URL like your IP4/basket, -3. What happens when you change the number to 2 or 1? It means there's a chance for you to view another person's basket. Or you can even modify another person's basket. So we'll try to see if we're able to do this. Let's say view someone else's basket, and then if this is possible, then we'll move it on from here. So we'll just go back to this. So if we click on this, we add to baskets. I have a basket here. What we could do is to log out from the admin since we've done that and log into our account which we created. This monkey@gmail.com 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we could just add this to our basket. Add this to our basket. Then this is my basket. To check what happens at the background, you see that there is a rest basket of 6. So I'm guessing this is my basket. So I'm guessing this is my basket. To send this to repeater, we would have the result of what I have in my basket. So as you can see, I have the apple juice and I also have the lemon juice. Check my baskets. I have the apples and the lemon juice. But what happens when I change this 6 here? What happens when I try to tamper with this figure? I change this from 6 to, let's say, 2. I've been able to view someone else's basket. You can see this is another person's basket because you're seeing contents from another person's basket. So it means we've broken access control. Let's try another number. It means there is no basket for this. Let's try another number. Okay, so you can see that yes, by changing the basket ID or this here, we've been able to view other people's basket. You can also try this another way. If we inspect this page, okay, let's make this big enough. We inspect this page, and let's check, let's see what's in the local storage, session storage. Okay, so this, okay. So I see something called BID. I want to believe this is the basket ID. And I see that there's a value of 6 over here. Now, which corresponds to the 6 I have on my own basket ID originally. Now, what happens when I change this from 6 to 2? Click on enter because we couldn't find any changes. What happens when I refresh the page? Okay, you can see the content of my basket has changed. Okay, so let's do 7. Okay, so we can find the contents of another person's basket. So we just been able to do that. We just go back to our own basket. Okay, so so by tampering with the ID of each basket, we've been able to break access control and perform horizontal privilege escalation by viewing other people's baskets. So we've accomplished the task right here. We just type in complete. Okay. Okay. Logging in as admin. So this says some websites fail to protect user accounts properly. Maybe they use easy to guess passwords, expose credentials somewhere in the sites, forget to lock down admin access. So for this lab, you're trying to log in as the admin, but no tricks, no SQL injection. The challenge is, can you find or guess the admin's real passwords? Your clues might be common passwords like admin, root, 1, 2, 3, 4, 5, 6, and password. hidden hints in source code and the likes, JavaScript files that leak credentials, forgotten debug information or comments, credentials we use across different pages. So your task is to log in as the admin using the real password. Submit the password when you're done. No injection, no hacking, just observe, explore, and think like someone who left a door open. Think like red team. Okay, so we have to find a way to break into the admin by using the admin's password. So first things first, good thing, we've been able to find the admin's password email address from here. Just so what we need to find right now is the password to the email address. So do we try admin 1, 2, 3, 4, 5, 6. Let's try password. Okay, it's not working. So what we could do, first things first, we want to store password. Just this should, well, if you go to our proxy, find that, push out the request and send to intruder. And then since what we are trying to brute force is the password, we simply just add our payload to be there. And then for payload, let's try to load this and then we use common passwords. And then this would run a brute force attack on the login field. That way, we should be able to brute force all of the passwords in the word list against the email address you provided it with. So we can open and have this. This looks small. So let's load another one. Let's see. Top passwords shortlist. This is also the small password. So let's keep checking. Okay, try to reduce this. So we'll set our payload position to be for the password. We'll set our payloads, which is the word list we want to use, and then we'll start the attack, and then we'll wait for it to complete and find which of them does not show us a 401. While we are doing this, let's, okay, it says you solved the challenge, login media administrator's results, credential without previously changing them or applying SQL. We need this challenge has been solved, but we are yet to find the password. So you could inspect and then check to see if we can find anything interesting here. This, okay, nothing interesting here. Let's go back to the keyboard and check, check for anything. Let's check for admin. Nothing of such here. Let's look at our intruder. This is done. So, okay, we find one that doesn't show us a we find one that doesn't show us a 200. You see a payload which says admin 123. And if we check the response, it seems like we're able to log in with this. So we try admin 123. We try and move 123. Shoot. Yes, and we're in. So we'll be able to log in doing this. One other thing we could try, one other way we could have done this, we logged in using SQLi before. Probably we should just do that one more time. This logged in using SQLi here. If we go to just a guess, and yes, yes. So we have an authentication token here. If we copy this token and try to read the contents of the token, because session tokens contain sensitive information about the bearer. So we should, if we use this, copy this token and we check jwt.io, which is used for which is used to decipher the content of the token. Let's put in our token here. As we can see, it's decoded this token for us. And we have the content having the success. We have the email. From here, we can have the email. You see the password, although this seems to be a hashed format of the password. You also have, you see the whole, the last login IP and all the content relating to this particular account. So, having found this, we could just copy this and find a way to dehash or produce crack station. Produce crack station. yes, we're able to find the password of the email. So we looked at two different, we've been able to identify two different methods that we use in finding the same password. The first was us brute forcing the password, which was a traditional means. Then the second involved us analyzing the web token on the, the session token or the authorization token on the admin user itself, which gives us everything we need to know about the user. We could try this by checking, could also do this, also try to confirm, also try to confirm by logging out and logging into our test account. 1, 2, 3, 4, 5, 6, 7, 8, and Yes. We are concluded. Okay.
All right. Thank you to all our participants, online participants. Thank you for staying to the end of the section. Now it's time for questions. If you have any questions, you want clarity on something you didn't know during the practical section, so the floor is open for questions. You can drop your questions in the chat, so we will attend to each question as it comes in. No questions currently. We will take your questions offline. For those of you that are already in the SciSec community, you can drop your questions there. We will continue from there. But for now, thank you once again for joining today's section. We hope it was insightful. We hope it answered most of your questions. And we look forward to seeing you next week. You can stay tuned. Um, During the week, we will be unveiling the next topic that will be treating next week's session. So stay tuned, and we look forward to another exciting section next week. To have a wonderful day, and thank you. Bye. I can end the meeting now.